Hello, everybody, and welcome to today's presentation, migrating from RavenDB 2.5 to 4.1 in 36,000 locations. Brought to you by RavenDB. Before we get started, I'd like to take care of a couple housekeeping items. First off, I'd like to make sure you all can hear me okay. So if you would, please post a message in the chat panel to let me know. Great. If you have any questions for our presenter today, please post those into the questions panel so we can get to them after the presentation. If you experience any technical difficulties today, like the audio dropping out or the screen sharing not displaying properly, please post a message in the chat panel to me, the host, and I will work with you to resolve those issues. Lastly, on the housekeeping list, we are recording today's presentation, and it will be made available shortly after today's event concludes. Now that we're through the housekeeping items, I'd like to introduce you to our presenter, Rodrigo Rosario. Rodrigo is a senior manager responsible for the architecture at RDI Software. With over 16 years of experience in software development, he has been working with RavenDB since 2013. RDI Software deploys RavenDB to over 36,000 locations worldwide, leveraging its embedded capabilities to improve their quick service restaurant software. Now I'd like to do a quick sound check for Rodrigo. So Rodrigo, if you would like to say hello, and the audience, let me know if you can hear Rodrigo by posting a message in the chat panel.
Hello, folks. Please let me know if my voice sounds clear to you.
Great. It looks like everyone can hear you. So with that, Rodrigo, I'm going to turn things over to you to begin the presentation.
Thank you very much, Billy. Thank you. Hello, folks. What I will do here today is to share my personal experience with RavenDB in what I consider to be a very interesting implementation, right? I'll tell you a little bit of our story planning the migration of RavenDB 2.5 to 4.1 in about 36,000 locations. Well, I was going to introduce myself, so Billy did a great job already, so I'll skip that over. One thing he didn't mention about me is that I have a developer background and I'm absolutely passionate about technology. But let me also introduce RDI Software, which is the company I work for. RDI Software is a wholly owned subsidiary of Capgemini. Here we design, build, and support restaurant automation and e-commerce software for quick service restaurants. And let me give you a couple of numbers, some numbers here from our operations. Our software currently runs on more than 37,000 restaurants, out of which 36,000 of those are running with RavenDB. Our estimated number of individual machines is around 500,000. So this means that our software is running in around 500,000 individual machines. And the same software is processing almost 420,000 US dollars per minute in customer transactions. So think about that. This means that during this webinar, the same software will be processing about $17 million. Well, when you get to this massive level of scale, I like to quote Gordon Letwin. Gordon Letwin, he was the original architect for DOS4. And Gordon used it to say that if you had a 1 in a million chance of a problem happening on DOS, it would happen next Tuesday. I identify myself with that quote because due to our massive scale deployments, the same is true for our QSR platform. When you are running on 37,000 locations, 500,000 nodes, 1 in a million is definitely next Tuesday or even before that. So before we talk about our migration itself to Raven 4, let's first understand how we started with RavenDB. Everything started in late 2012 or beginning of 2013 because we were completely redesigning the architecture of our system. And as part of that redesign, we wanted to find a good solution for the data persistence layer. So we started this search for a database management system. We wanted to find a database management system that would fit our needs. The new architecture that we had just designed, it had some goals and guidelines related to the persistence layer. The first thing is that this architecture was based on microservice. And if you don't know it, one of the principles of microservices architectures is that each microservice must have its data completely isolated from the others. So this means that all the integration must happen by APIs, masters, and things like that, never through the database itself. So we wanted that each individual microservice should have its own isolated database. We also needed zero administration, which means no human intervention at all, because we can't afford to have 37 or 36,000 DBAs, one for each restaurant, for example, to install, to configure, to maintain a database system in those locations. We want something that is able to administer itself. Because of the massive deployment scales that we have, we're typically running on dozens or dozen different software releases in the field, right? We don't have a single version running on those 36,000 restaurants. This means that during a software upgrade, we may be upgrading from a very old release or a very recent one, and we must support all the possible combinations of that without losing data. For that, we wanted to have very easy schema upgrades somehow. So we wanted the schema upgrades to be smooth and easy as possible. We also wanted some form of transparent replication because in our previous architecture, we had to manually implement what we call failover scenarios. Those kind of scenarios where a machine goes down and you need to start a software component in another one, but you don't want to lose data, right? So in the past, we had to manually code all the data replication mechanisms for that to happen. In the new architecture, we wanted the persistence layer to handle all that complexity for us transparently without too much coding. Also, the new architecture had a lot of focus on test automation, so we wanted a persistence solution that would allow us to implement unit tests that were very fast to run, but without having to mock the database every time. Because every time you're mocking the persistence layer, you may be skipping a couple of bugs. So we wanted something that allowed us to run unit tests very fast. So during this process, this seek for, or this search for the DBMS, right, the database management system, we did a lot of proof of concepts. Actually, we evaluated options and created proof of concepts for more than 6 months before reaching a final definition on RavenDB. So let's go over a couple of reasons why we chose RavenDB. To be honest, there were way too many areas that we evaluated to bring here to the presentation. So I would just highlight a couple of those that contributed to the final decision. The first one is RavenDB is a .NET application, as is our platform. So our quick service restaurant platform is currently written in C# running on .NET. So this is smooth .NET integration with support for C# link wheel queries and things like that helped a lot. Also, it had what we needed, which was an embedded operation mode, including 32 bits support. Our software still runs on a lot of 32-bit machines, so it was very important to us to enable 32 bits at the persistence layer, right? The embedded operation mode is also very good for zero administration. It was one of our guidelines, one of our requirements. RavenDB also has this in-memory mode, which is very handy for unit tests, and it's fully multi-tenant, which is great for microservice. Multi-tenant here means I can start a single RavenDB server, and the same server will be handling dozens or hundreds of databases transparently. So that's the perfect fit for microservice, because we can literally have each microservice instance to have its own isolated database. And RavenDB also had some very good transparent replication options. So we defined that we would use RavenDB, started developing our platform on top of it, the new architecture. What did this bring to us, right? So what did we achieve with RavenDB right off the top, right off the start? Well, basically, it allowed us to tackle all those areas that we had concerns. For example, we were able now to create unit tests without mocking the database, but still running very fast. All the transparent replication options from RavenDB allowed us to implement very cool stuff, such as hot standby failover, data distribution mechanisms, real-time backups, things like that, with very little effort and coding. Also, now we had advanced statistics about the data persistence that we didn't have before. Both system-wide and per microservices statistics is great for investigations. But more importantly than all those things, it allowed us to do faster development. We actually found out that the NoSQL document store paradigm fits really well into the domain of line of business of applications, which is our case. But all that was not without challenge, of course. So let's talk about some of the challenges that we faced over this course. Our first challenge was related to hardware constraints. Our software does not run on those typical data center server class hardware. Not at all. We're actually very far from that. The typical hardware that we run looks more like this. We are running on specialized old hardware. When I say old, I really mean old, sometimes more than 10-year-old. This means that we have very little memory and processing power available to us. What happens is this sort of restriction can trigger some very interesting problems. And remember, 1 in a million is next Tuesday for us, right? So of course that we bumped into those problems. We had, right in the beginning of our mass deployments, we had issues with memory utilization in some of those locations, right? So the way we handled that, we had many iterations with the RavenDB support team to fine-tune its memory utilization for this particular scenario. What we learned in this process is that under these kind of severe constraints, caching can be evil. RavenDB has a lot of smart caching, but our memory and hardware constraints are so huge that it couldn't do so well. In the end, the solution for that problem was to completely disable caching on RavenDB itself, and then do some caching at our application site. Then we can cache only what we call the hot data, only the data that is actively being modified. That was how we handled that. Our second challenge was much more complex to others. Running Ascent on 36,000 locations was no fun at all. For those of you who don't know, Ascent is the underlying storage engine that is present on Raven 2.5. It is a Microsoft storage engine. The problem with Ascent is that any unclean shutdown may cause a completely undetermined result. So those things like power outages, application crashes, someone going and killing your application using a task queue, these kind of scenarios, they can be very problematic to us. The possible results from those scenarios are not easy to find out during the regular testing, the regular application testing. And believe me, during the proof of concepts and during the implementation, we tested a lot of power outage scenarios, for example, to see how the application would behave. But those are the kind of issues that only manifest in the field, the 1 in a million kind of problems that we get when we get to this massive scale of deployment. So what we did is we had to spend a lot of effort to automate all the possible recovery scenarios, all the possible recovery situations that Ascent could face. That was not very fun to do. Even today, I must confess, we still face sporadic full database losses with Ascent. That is quite frustrating for us when it happens. Another fact of Ascent is that copying data between OS versions is quite awful. It's not convenient at all. The reason is that Ascent is tied to the operating system and its underlying storage schema is also tied. So when you go and copy data, for example, from a restaurant that is running Windows XP, and you copy that to a Windows 10 machine, you need to do a full Ascent schema migration before you are able to look into that data. So you may be wondering at this time, why are we still running RavenDB 2.5 nowadays? Why didn't we migrate to, for example, Raven 3 or 3.5 and leverage Voron, the new storage engine that was created on those versions? Well, there's a couple of reasons. The first one is our software still had to support Windows XP embedded until very recently. Only our next major release will be able to completely eliminate support for Windows XP embedded or Windows XP. This means that we are still tied, we are stuck with .NET 4.0. Raven 3, Raven 3.5, they unfortunately required more recent versions of the operating system and of .NET. Not only that, we are still tied to 32-bit machines, which means that using Voron, the new storage engine, on Raven 3 or Raven 3.5 was still not an option because Voron on those two versions, it didn't support 32-bit machines. Well, all of this means that Ascent was our only option so far, right? So that's what we have today. Now, with the official end of life of Windows XP, the Windows XP extended support from Microsoft. For those of you who don't know, Windows XP extended support is not there yet. It's still not ending. It will happen only December this year, right? With the official end of life happening December this year, we finally could start planning our migration away. So what we did is a couple of months ago, we started a new project to migrate to Raven 4. As our next software release will not support Windows XP anymore, so this allows this kind of decision. So now let me share my experience during this migration project, what I consider to be the good, the bad, and the ugly. Let's start with the good. The first and most important benefit of RavenDB 4 for us was the new and redesigned Voron storage engine. What happened is that during the design of Raven 4, the RavenDB team understood the importance of supporting 32-bit OS for embedded deployment scenarios, which is our case. And they committed to add support for that deployment scenario, 32 bits, on RavenDB. This finally allows us to say goodbye to Ascent, even on 32-bit machines. And what we found out with Voron when testing is that Voron has a much better reliability, has much better support for ungraceful shutdowns, which is great when you're running 36,000 locations and someone can bump in the power cord, right? And not only that, but we could also finally remove from our source code all the Ascent automation logic that we had included. This means that we deleted hundreds and hundreds of lines of code that we had to maintain and test every release. The second benefit was the improved performance. Not only the raw performance, but the thing is that RavenDB 4 is able to scale from very low-end hardware, such as the one that I had a couple of slides back, remember? So it's able to scale from very low-end hardware up to large sharded clusters in the cloud, handling massive amounts of data. We did many tests on that area, and we found out that Raven 4 can actually achieve performance that is similar or better than more well-known competitors such as Cassandra and MongoDB. Well, it happens that we are already designing our next generation QSR platform now, which will support those two very different deployment models. So what we are designing is a platform that will run both in the restaurants as we run today, on-premise deployment in very low-end hardware, but it also will support cloud hosting for what we're calling a point of sale in the cloud, right? So RavenDB 4 enable us to have a single technical solution for those two completely different scenarios. RavenDB 4 enables the next generation evolution for our platform. Also, the new studio is much better than the old one, I must confess. We didn't really like the old one. And it comes with the added bonus that we can finally stop installing and maintaining Silverlight on 36,000 locations. That was not very good because Silverlight, as many of you may know, is not a well-supported application anymore. So goodbye, Silverlight. Additionally, the Linux support that was added on Raven 4 may enable some interesting deployment models in the future for us. This is something that we are actively investigating and researching our options, but it's not something that we are leveraging right now. Well, I promised that I would tell the good, the bad, and the ugly. So let's go also over some challenges that we faced in this process. The first challenge we had with Raven 4 is that it does not automatically migrate data from Raven 2. So we had to implement all the orchestration for that ourselves manually. And the thing is, fully automated data migration on 36,000 locations, that is hard. It's not something easy. Because remember, we can't have human intervention. We can't have 36,000 DBAs going to those restaurants and doing the data migration manually. And so we had to automate everything. And when you do that and you are remotely upgrading important things, things can go wrong during the upgrade process. So for example, someone can bump into the power cable during the process. You can have a legitimate power outage during the process. Bad things can happen. You can have a lack of disk space. There were way too many exceptional scenarios that we needed to account for. Also, the lack of real embedded mode, or the lack of embedded mode on Raven 2.0 or Raven 4.0 was quite challenging because we had to implement everything ourselves to continue achieving zero administration. So we had to implement from the packaging of the server binaries to the process management and automate all the control of that server process. Raven 4.1 brought back support for embedded mode, but this new embedded mode in 4.1 didn't really solve our problems. Because on 4.1, the embedded mode has the assumption that the .NET Core runtime will be pre-installed in the operating system somehow. And for us, managing software prerequisites in 36,000 locations, it's not trivial. So we would prefer to just ship the .NET Core runtime side by side with our application. And that's what we did. So the way we're handling RavenDB 4 right now is that we're shipping 2 complete copies of it with the full .NET runtime, one for 32 bits, one for 64 bits, and then deciding which one to start during the application startup. Also, we way underestimated the migration effort when we started it. We spent approximately 1,200 man-hours in this migration over a 5-month period. So that's pure development and testing effort to migrate our platform. Some backward incompatible changes made it much harder to migrate some features. And in order to achieve zero maintenance, it was quite challenging because we need to take care of some exceptional scenarios, for example, such as automatically exporting data and re-importing data in case of catastrophic failures, things like physical data corruption, preventing the database startup, but we still have to support somehow the application to start up. Well, the good, the bad, and the ugly, right? The ugly is we are not prepared yet to maintain TLS and SSL certificates with such a large number of nodes. Obviously, we know it's achievable, but we were not prepared for that. We're running, remember, on 500,000 nodes. Those are fully offline nodes most of the time, so there's no way we could leverage things like automatic renewal of certificates, let's encrypt, things like that. So in order to remove one of the variables of this already complex migration, we decided to just go for now with plain unencrypted HTTP connections. The reason for that is, first of all, we want to remove one more variable, and also we are already running inside full trust environments anyway. So we didn't have any issues with plain HTTP so far. The problem with that is now one of the features that we used to use the encryption of data at rest is now tied to the usage of SSL certificates. The encryption of data at rest is the full database encryption from RavenDB. So we had to temporarily drop that feature from our system and we will reintroduce it in a later release when we start using TLS and SSL certificates. Right now, as a mitigation strategy, we are using field level encryption at the application layer to replace it. So that's the ugly of it. Well, let's talk about our current status in the migration and our future plans. First of all the development and testing for RavenDB 4.1 in our platform is completed now. We do have a new major version of our software that will be released around December or January. That will include RavenDB 4.1 in all the migration strategy, right? All the data migration that I mentioned. The migration of all the 36,000 locations, it's not something that you do overnight, right? It will most likely take the whole year of 2019. We need to remember that we are talking about multiple countries here, and each country, each market has different characteristics and different deployment timelines that we must respect. So even though we could technically do it in a very short time window from the application perspective, we still have those challenges to overcome. That's why we don't believe we will be fully migrated to Raven 4 before the end of next year. Also, as I mentioned before, we are already designing the next generation of our platform. The next generation is what will run both in the restaurant but also and in the cloud, right? So that's what we are calling cloud-centric capabilities. Those will start to be implemented early next year, and our plans is to leverage RavenDB 4 to enable most of those capabilities. As I mentioned before, one of the big benefits that we're seeing with RavenDB 4 is the ability to scale with the same technology between very low-end restaurant-level hardware to large sharded clusters in the cloud and processing huge amount of data. Well, this was a little bit of my experience with RavenDB running at massive deployment scales and the challenge that this brings to us. The migration project is still undergoing, as we still need to really migrate all the restaurants, but we are now very comfortable with the solution that we have in our hands for that. Before we finish, I would just like to take this opportunity to say a big thank you for my team, the RDI team, because without a very good team, nothing of this would be possible. I'm sure that very few teams around the globe would be able to achieve what we are achieving here. So thank you very much. And I believe it's time for questions now.
Awesome. Thank you so much, Rodrigo. We do have a couple questions that came in. Our first question is, what solution did RavenDB replace? And how does it compare?
What solution did RavenDB replace and how does it compare? Well, we had an in-house persistence solution, so we didn't have any off-the-shelf solution before or any relational database management system or anything like that. This in-house persistence solution was based on event sourcing. So the problem with this in-house solution is that we had, for example, no query support at all. So every time we needed any new data type or any new query, right, reading information from the data storage, that required some heavy coding, a lot of coding to aggregate the right data at the application during the application startup time. So that's how we had it in the past. It was not very cost efficient because of all the effort we had to maintain it. And that's what we completely replaced by RavenDB now.
Awesome. Our next question is, how do you integrate all 36,000 locations data to get a global view?
How do you integrate all 36,000 locations data to get a global view? That's a very good question. We do have what we call a global data warehouse that is responsible to consolidate all this data. How we do it is that we upload data in large batches, typically XML files with the data, over the night. So it's not a real-time or near real-time replication right now flowing to the global data warehouse. We're talking about massive amounts of data here. Remember, $420,000 per minute. That's a lot. So we don't really need real-time data aggregation in the global data warehouse. The global data warehouse is a polyglot persistence, so it's not using a single data storage. It's using multiple different data stores to achieve all the different needs that we have for big data and analytics and reporting.
Wonderful. The next question is, given that your situation is relatively rare, would this work on a smaller scale, like for a healthcare system that may have 10 clients, for example?
Yeah, that's a very good question. Not many clients would have 36,000 locations, I agree. My opinion is yes, absolutely it would. The same strategies that we created would work for smaller scale. Obviously, there is some economies of scale in our implementation. So, for example, it may not make sense to automate the whole data migration process and spend all the hundreds of hours, development hours you need to do that if you only have 10 sites. On that particular scenario, I would probably just go ahead and do some of those migrations manually. Some of the zero administration challenges actually go away if you have a smaller scale. But I think that overall, the same implementation, the same architecture with RavenDB would work pretty well, yes.
Great. Our next question is, did your use of replication change from RavenDB 2.5 to 4.1?
Did our use of replication change from Raven 2 to Raven 4? Yes and no. So what happens is Raven 4 has this concept of clusters, right? Using the RAFIT distributed consensus algorithm. For our deployment scenarios in the restaurant, it was not a good fit. The clusters in RavenDB were not the ideal fit, and the distributed consensus algorithm was not what we were trying to achieve. So the only change that between 2.5 to 4.x was that instead of using regular replication, which would be now clusters, we are using what RavenDB calls external replication. External replication on Raven 4 can target two types of database. So it can target regular SQL database, such as Oracle, etc. But it can also target regular RavenDB instance, right? So that is what we are leveraging, because we do have different replication mechanisms. We have replication mechanisms that are active, so they are master replication. We do have master failover replication for other ones. So that's how we're achieving that different strategies. We're just leveraging the RavenDB external replication for that.
Great. The next question we have is, when it comes to Raven in the cloud, how is it deployed? Is it on VMs, or is there another way?
So when it comes to Raven in the cloud, how is it deployed? In a VM or other way? To be honest, we didn't get there yet. During our proof of concept that we did in the beginning of the year with RavenDB for alpha and beta, etc., we did use regular VMs. Now that we are more mature, probably the way we're going to choose moving forward is using Docker containers for that. Obviously, with all the data storage outside of the Docker, but you got the point, right? So the idea when running on the cloud is to have a dedicated cluster, probably a large cluster with sharding in order to support the level of data processing that will come with a point of sale running in the cloud.
Great. The next question we have is, what was the point to move RavenFS as an attachment in version 4?
I will apologize. I don't think I understood the question. So what is the point of moving RavenFS?
Yes. The question was, what was the point of moving RavenFS as an attachment in version 4.1?
Okay, I got it. So it's RavenFS, the Raven file system, right? To be honest, we are not using RavenFS at the moment. So that was not a feature that affected us. I believe from the question that this is a deprecated feature or something like that on 4.1. Unfortunately, I don't have experience with that to be able to answer that. But it's not a feature that we were using as a client of RavenDB, so it didn't affect us at all.
Awesome. Looks like we have one more question, and that question is, how do you compare your new graph coming up versus Neo4j?
So the graph query length or the graph capabilities that Voron and hibernating rhinos are designing, honestly, I'm not following too much what is the current status on that. It may come handy for us as a client in the future. We don't know. We'll probably just wait for the final implementation to come up because we do have some utilization of graph database today, specifically Neo4j. So in the future, probably we will evaluate the possibility of having a standard storage engine that is able to handle both the regular data storage and the graph data storage. But let's wait and see. I believe that's a feature that is still heavily under design. It's not yet completed. It's not yet fully implemented and designed.
Great. Rodrigo, is there anything you would like to add before I close things out?
I don't think so. I'm good. Thank you very much, Billy, for hosting this. If we don't have any additional questions, I believe we can close out here.
Great. Well, I'd like to thank you, Rodrigo, for a great presentation today. I'd also like to thank today's sponsor, RavenDB, for providing the audience with a great webinar presentation. And lastly, thank you to everyone who attended today. We hope you learned something new that'll help you in your developer career. Have a great day, and we will see you next time.